Hi guys, this is again the last minute revision for the section on coordination compounds for your HSC exam, which is going to be there in the couple of days. Okay, so this particular section consists of three parts, as you might be aware. The introductory part, the bonding part consists of valence bond theory and crystal field theory, followed by the section on organometallic compounds, right? So I would recommend that don't leave anything an option in this topic again because it's pretty much easy and interesting provided that you find it interesting. Okay, so this topic has a lot of things that you should understand. The IUPAC nomenclature in coordination compounds is a must. You should do it. The basic things like types of ligand, the structure of ligand, the polydentate ligands, right? And then you have the bonding. In bonding section, you have the valence bond theory, the postulates, and then there are few complexes whose hybridization has been done, and I would recommend do each and every single complex which is there in the textbook. Okay, and then crystal field theory, what exactly is the elementary crystal field theory, and then spectrochemical series. If you could do the questions based on crystal field theory, it would be useful even for your entrance exam. But anyway, the choice is yours. But valence bond theory is a must in this case, and spectrochemical series, like how the splitting of d orbital takes place, what are strong field, weak field ligand, and strong field ligand form low spin complexes, weak field ligand form high spin complexes, right? The examples of them, right? And then comes the very easiest part, that is what is it, organometallic compounds, right? Organometallic compounds, there are just synergistic bonding, metal ligand interaction, the sigma and pi bond formation, followed by structure of few metal carbonyls, out of which few are very simple, they are the normal ones, and other ones are the bridged carbonyls, right? So it's not that difficult. Correct. So let's see what exactly, this was just an overview. So let's see what exactly are you going to do. Okay. So I would recommend that you do not miss these: Werner's theory, the primary and the secondary valency, EN rule, that is Z minus X plus Y. The total should come to, like this particular term should come to the nearest noble gas, types of ligands and complexes, monodentate, polydentate, ambident, yes, isomerism, very important, especially especially the linkage isomerism and the structural isomerism. The geometrical, if you can do it, it's well and good. Otherwise, like it's your call. But structural isomerism, you should do it. Then the IUPAC naming, the valence bond theory, do all the complexes I've already said. The crystal field theory, the metal ligand metal ligand interaction in three-dimensional field, right? And then structure of carbonyl complexes and the synergistic bond. And make sure that you are doing the merits and demerits of VBT as well as CFT. VBT was not able to explain why the same metal forms high spin and low spin complexes when the different ligands are there. That means ligands do play certain very important role, right? So these things you should not miss. They are very easy, right? Again, the section on isomerism, please do it. Okay, especially the what do you say, the ligand isomerism, linkage isomerism, coordination isomerism, right? And linkage isomerism, which is basically done by ambident ligand. There are exclusive examples which you should go through. Okay. Then learn these things: strong field, weak field ligand, ligands which bring greater degree of splitting, they are strong field, they form low spin complexes, and if the splitting is less, it is weak field, they form high spin complexes. Then the spectrochemical series, arrangement of ligands in order of their field strength, possibly basics of crystal field theory, the merits and demerits. If you can do everything, it would be great. Okay, it would be absolutely great. Then, as I said, the section on organometallics. What are organometallic compounds? Wherein there is metal carbon bond and the synergistic bonding between, the sigma and pi bond formation, and the structure of carbonyl, the bridged carbonyl as well as the normal carbonyl. These are the things, and yes, most important, they could give you something like applications of coordination compound, qualitative analysis, titrimetric estimation using EDTA, right? And metal complexation studies, radiotherapy, right? Heavy metals, removing heavy metal in the form of a complex, right? So please do the applications properly. Four at least you should remember. Okay, so this was about the section on organometallic compounds, the coordination chemistry. I hope you are now going to be facing the exam, so it's going to be pretty much challenging for you. So I wish you all the best. The next session is on the base for the D and F block element. So stay tuned.